This video tutorial covers how to use a line chart in Dream Report. A line chart is a Dream Report object which enables you to display data in a historical trend or in a line chart. To use a line chart, first of all, you select the line chart object in Dream Report Studio and place it on a report. Then select one or more tags to plot. Select the plot type for each tag, for instance value, moving average, linear regression, etc. And then select a time period to plot for each tag. Each tag can actually have its own time period. Finally, set line and marker properties, scaling, legend, grid, and other display options. The result are feature-rich trends to include in your report. In this video tutorial, we're going to demonstrate how to create a basic line chart, a line chart with multiple analog and discrete tags. We'll compare a tag over multiple time periods, create an XY chart, create a batch-based trend, filter data to be plotted in a trend, create a chart from the results of a SQL query, demonstrate how to set scaling, grids, line types, legends, and just general appearance options, and finally work with interactive charts in the Dream Report web portal. So let's launch Dream Report Studio and open an existing project. This project has already been configured with data sources that we'll create trends against. We'll create a new report, give our report a name, then we'll add a line trend chart to the report. Go and select a tag. We'll choose our temperature 1. We'll choose a time period, for instance the last 10 minutes. Add that line to the chart. Select another pen, add that line. We'll leave all other defaults the same, and we will run our project. When we generate this report, we should have our basic line chart displayed with data for temperatures 1 and 2 for the last 10 minutes. Despite the ease and simplicity in which you can create a line chart, the chart object has a rich set of features and capabilities that we will explore further in this video. These features include up to 128 pens per chart, adjustable scales per pen, the ability to create multiple lines for the same pen, for instance, if you were comparing a temperature over different time periods, XY charts, the ability to change line color to highlight a specific operating condition, to name just a few. So let's take a look at our first use case scenario. Here we'll create a chart on 3 tank levels, show a motor or pump status discrete tag on the chart, and show the tank levels relative to the pump starting and stopping. We'll add our tags one by one. Our tank levels 1, 2, and 3. We'll set our time period for the last 10 minutes. We'll set a legend caption for each of our tags and set our pen colors. Finally, let's add our motor tag, which will indicate our pump status. Set its color, its legend, add that line, and note that we won't show an X or Y axis scale for the pump status, but we will show 3 automatic scales for the tank levels. Axes for each tag can be shown, hidden, or shared with other tags. This might be useful if you had 3 1,000-liter tanks, so it might make sense to use the same scale for all 3. Now let's go to the Appearance tab and set a few display options, some of which we'll describe in more later on. We'll give our chart a title, show a legend, change the grid color, and manually set the Y scale for the pump tag to offset it from the analog tags, and set the plot type for this tag to be time-based. We'll explain this feature later, but for now we use this plot mode whenever we're displaying a discrete tag. Let's save our report and then generate it. Note that the pump status is shown as a square or on-off plot overlaid over the 3 tank level tags. Also note the 3 Y scales for each tag and the legend below the chart. Looking at use case number 2, we'll do a monthly comparison of a temperature tag over the past 3 months. We'll add the same tag to the chart 3 times, but change the time period for each pen. We'll make sure to show individual x-axes for each pen to show the 3 monthly plots. Additionally, we'll use the Advanced Display option to change the line colors to red if the temperature exceeded 90 degrees. So we start off by selecting the Temp1 tag. We set the time period to be the last 1 month, set its legend caption, and add that line to the chart. Since we're using that same tag, all we need to do for the next pen is to change the time period to the last 2 months with a duration of 1 month, which will give us data for 2 months ago. We then set this pen's color and legend, and then add it to the list. And finally, we repeat the same process, but this time set the time period to be 3 months ago. Now we select each tag and ensure that the x-axis is displayed and tied to its own time period. The tags will share the same y-axis scale. Clicking on the Appearance tab, we give our chart a title, and then for each pen, click on the Advanced Option button to set the line color to red if the value exceeds 90. We could use multiple breakpoints and assign a different line color to each value range. Please note that these limits or breakpoints can be either static numbers, as I'm doing here, or by double-clicking on each field, we can browse for any object on our report or for a real-time value, and have variable limits. Here we'll select our engineering units for the Y scale from a predefined list, or add our own units to the list. Set the grid color and resolution, which we'll discuss in more detail later. Set the legend to be displayed below the chart, and then save. And now we generate our new report. Note the 3 x-axis timescales corresponding to the previous 3 months, and also that the line color changes to red whenever a value exceeds 90. In this third use case, we'll create an energy signature chart, which links energy consumption to ambient temperature so that a building's sensitivity to temperature can be monitored. It's a special XY chart where the y-axis displays energy consumption and the x-axis displays external temperature. We plot this line as a linear regression instead of just raw values, and we will use a line with markers for the line style. We place a new line chart on our report and select the Energy Consumed tag for the y-axis. We'll then set the time period to be the last 3 months. And then for the x-axis settings, instead of showing date and time, we'll select another data item or tag to create this XY plot. We'll select the exterior temperature tag for the x-axis. Let's select a line color and thickness, and then for the line style, we'll select line with mark. For the process value, we select linear regression, and then we add the tag. Finally, under the appearance options, we enter a chart title, and we're done. Let's go ahead and save and reload the report. And then we'll generate it. So there we have an energy signature chart for the last 3 months. In this next section, We show how to filter values to plot in a line chart by utilizing the advanced SQL condition filter option, which is available in most objects in Dream Report. In the following example, we'll show two identical charts displaying a temperature tag. In the second chart, we'll filter out any temperature values below 20 degrees and above 60 degrees. I'll quickly place a line chart on this new report with the temperature tag for the last 10 minutes. Let's give it a title and click OK. I'll now copy and paste this chart, open its properties, and change the title to indicate that this is filtered data. Next, I'll click the Advanced SQL tab. To create the data filter, I select the data item I want to filter on, and then click the Add button. From there, we can build the filter expression. For those familiar with the SQL language, this would be the where expression in a query. Click OK, and we're ready to generate the report. And there we have values plotted that only fall between 20 and 60. There might be times where you want the source of data for your line chart to be the results of an SQL query. In this section, we'll use a few different SQL queries and stored procedures to feed our chart. Let's start off by creating a new blank report and then place a line chart on the report. Now, instead of selecting a data item for our pen, we go to the Process Values section and select SQL Query from the list. We then click the button to enter our SQL query. We use an ODBC connection to any SQL database, which I've already created and tested, and then enter the SQL statement. I'll paste a query that I've tested in Microsoft SQL Server. Make sure to test the SQL syntax in the database environment. Now that we've entered the SQL query, click Add Line. Let's display the legend and then run the report. You'll notice that the legend was created for us using the field names or aliases returned by the SQL query, which we'll see in the actual query. While we're in Microsoft SQL Server, let's look at a second SQL query, which gets tank temperatures over a time period. Let's copy this query and then return to Studio to our chart object. I'll select the SQL query again and paste it in this new query. We then add this new query as a line. Make sure that it has its own y-axis scale. And then we save and generate this updated chart. Notice now that there are two additional pens added to the chart and legend, and a second y-axis has been added for these temperature tags returned from the second query. We're now going to look at what to do if the SQL query returns data which is not timestamped, as shown by this query. I'll copy the last chart and update it with this new query. Finally, since we don't have timestamps to use on the x-axis, we use the Show Relative Time on X-axis option, and we'll see the results of this when we generate the report. Let's save and reload the report. Looking at the x-axis, we see it in divisions numbered up to 90, which corresponds to the 92 rows returned from the query. And the timestamp has been removed from the x-axis. Let's take a copy of our chart again, but this time we'll use the results of a SQL stored procedure to feed the chart. This stored procedure takes 3 arguments: a start time, an end time, and a temperature threshold. It will calculate the average tank levels whenever the temperature exceeds the limit used. Now I'll change the x-axis to show the date only, and then generate the report. So there we have the average daily tank levels calculated whenever the temperature exceeded 50 degrees. The last feature we want to show here is that you can take any part of the SQL query or stored procedure and make it dynamic by referencing one or more objects on the report or in the project. We'll add a single data object to this report, which will display the current temperature when the report is generated. I'll give it a name, Temp Now. I'll select our Temp1 tag, and then from our list of statistics, choose Current Value. Getting back to our SQL query, we will modify the temperature limit parameter from being a static value of 50 to point to the Temp Now variable. We do this by clicking the Add Dynamic Token button and then selecting Temp Now. There you see it added as a dynamic token to the stored procedure. When I regenerate this report, you will see the current temperature shown at the top of the page, which is then used in the stored procedure. This next section looks at different scale limit options for the y-axis. In this example, we'll add the same tag several times, but for each pen, use a different y-axis scale limit setting. The first pen will use the default automatic scale. At report generation, the chart object will automatically detect the minimum and maximum of all values which have to be displayed for that line, and then automatically set the scale limits accordingly. The second pen's Y scale will be set to automatic zero-based. In this mode, the chart will automatically detect maximum of all values to be displayed, and then set the max scale limit according to that value. The minimum scale limit will always be 0 in this mode. For the third pen, I'll select manual or item-based. In this mode, a user can manually enter a value for the min and max limits for a scale. These limits can be static or dynamic. We'll use static limits of 40 and 80 for now. And finally, for the fourth pen, we'll use the auto-centered scaling mode. At runtime, the chart object will automatically detect the min and max of all values to be displayed, and then will automatically center the scale limits. Let's save this report and then generate it to see how the different scale options are displayed for the same tag. The legend shows us how we've scaled each pen color. You can pause the video to review how each pen color has been scaled. Finally, I'll demonstrate how to dynamically set the min and max Y scale at report runtime. I'm going to create a single data object which calculates the average temperature for the last month. I'll then use two expression objects to calculate the lower and upper limit values from the average, which I'll then reference in my chart. Of course, these values could come from any object in the reporting project. Let me add this pen once more to the chart and again set the scale limit to be manual or item-based. But this time, I'll double-click on each limit field, which will allow me to browse for the calculated values. When prompted, we select the internal analytics driver, which will then expose all objects from every report in the project. So let me pick my lower and upper limit values. When I generate the report, you can see the calculated lower and upper limit values on the top right, and the Y-scale references these values at the moment of report generation for the dark gray pen. We're now going to look at using a batch definition as the time period for a line chart. I've already created a basic report that shows the last batch that ran and the batch start and end times, which of course will be variable from batch to batch. If I click on the batch definition icon, we can see that this batch is defined in an external database. While we're in the batch definition, let's also select batch 80 as our golden batch. We'll refer to this golden batch later on. Now, we'll paste a line chart from one of our earlier reports, and for the time period, instead of using a fixed period, we'll select batch based, and then select the last one batch. For the x-axis, we'll show relative time as well as absolute time. This is useful for a batch-based trend, where the relative duration of the data rather than the actual timestamps is more useful. Let's set a couple of appearance options, and then we'll be ready to test this report. Once the report is generated, we can see the batch ID and start and end times in the report header. The line chart then uses this time period to plot the data. The lower part of the x-axis shows the absolute time that this batch ran for, and the upper part shows the relative time. What we now want to do is compare the temperature for the last batch against the temperature recorded for the golden batch. I'll copy this chart and then add the same temperature tag. We could still show the relative times, but I'll uncheck this option to show the different time periods that these two batches ran. They can share a y-axis scale, but each pen will use its own x-axis for the respective date ranges. For this second temperature tag, shown in brown, instead of using the last one batch for the time period, I'll select golden batch, which I had defined as batch 80 earlier on. So, after generating the report, we see the same tag plotted, but once for the last batch in 2014 and once for batch 80, which ran back in 2007. In this next section, we'll explore the various appearance settings in more detail that I've touched upon in the previous examples. These settings include legends, displayed units, grids, chart layout, and line plot types. I'll copy a chart from one of the earlier reports and use it to demonstrate these display options. First, let's click on each pen and add a legend caption below. Then, in the Appearance section, I'll check the Display Legend option. Once that is checked, I can now set the location of the legend, below or on the right side, and the font options. Let's take a look at what this looks like on the report. Now let's look at the Y scale. As I mentioned earlier, each pen can have its own scale or be shared with the scale of another similar pen. We select each pen in the list on the left and then set these Y-axis options. First, we decide that the scale will be displayed for this pen, and then we choose which pen scale it will be tied to, either its own scale or that of another pen. Note that the first pen added to a chart always has its X and Y scales displayed. And here is the result of those selections. I want to explain the color icons next to the tag names in the legend. Temp1 is the first tag added to the chart, so its X and Y scales are displayed. Blue is the selected pen color, so a blue square is shown next to temperature 1 in the legend. For Temp2, we see 3 small icons, 1 green square and 2 different blue triangles. The green square indicates that this is the color for the temperature 2 pen. The blue triangle pointing to the left indicates that Temp2 is using Temp1's Y scale. And the blue triangle pointing down means that Temp2 is using Temp1's X scale. If Temp2 was using its own X or Y scales, these triangles would not be shown. I just want to remind you that you are not limited to plotting the raw values of each pen. We have shown several examples where we've plotted a moving average or linear regression as examples. The process value option is where we select these plot types. While we're on this screen, you can also set the graph style independently for each pen. The choices are line, line with mark, and mark only. This is also where you would select line thickness and style, such as solid, dashed, etc. For the chart title, we can set font options and placement of the title, left, right, or center justified. The Display Options section allows us to show or hide various elements such as the title, legend, and grids, for example. And there you see the chart title left justified and only the Y-axis grid lines shown. We'll now take a look at the grid settings, which allow you to set spacing for the grid lines and grid color options. You might want to use a pale grid color so as not to obscure the plotted pens. Here we have a pale gray grid. The 2 default grid settings are fine, where the grid will subdivide the chart object into small cells via fine grid parameters, and normal, where the grid will subdivide the chart into slightly larger grid divisions. The manual setting allows you to set the X and Y grid spacing in millimeters. We'll set these both to 15 and see the result. If we choose Align to Values, we can select a time interval for the X-axis and a value interval for the Y-axis. Please note that the Y-axis interval you set will be impacted by the overall scale of the first pen on the chart. If, for instance, that scale was from 0 to 10,000 and you set a Y-scale grid of 10, the chart would show very tightly spaced Y-axis grid lines. We've already looked at the scale limit mode detail, so let's move on to the deviation setting. The deviation setting enables you to filter all item values and plot a line only on significant values, optimizing a chart line and avoiding minor value changes or noise in the signal. The deviation in percentage will analyze an array of item values, and each next value will be ignored if its difference is less than X% from the value of the previous valid point. The deviation value setting looks at an absolute change in that pen's engineering unit from one value to the next. If the point-to-point difference is less than the defined deviation value, that next point is ignored. Let's save this report and then generate it. Notice in the second chart that significantly fewer data points are plotted. It's got a smoother plot, but we still have a good idea of the data trend. I'll now go through some of the chart color options that were introduced in version 4.6. These are found in the Chart Area Properties section. Background colors are useful to add contrast to plotted pens and also for visual impact on a report. Let's take a look at a few of these options, which include solid, zebra, which is alternating colors, and gradient from one color to another. There are several ways to enforce a static value to be plotted. So in this example, I'll demonstrate the manual entry feature of the line object. I select a new pen color, which is red in this case, and then go to the manual entry settings. Click Add to enter a static value. We'll use 55 for our limit and give it a timestamp range of now to some arbitrary time out in the future. This will ensure that this pen is always plotted across the time span of our trend. I'll set the axis options so that the static line is displayed correctly and choose a dashed line style. So let's save this report and then we'll generate it. Here we have the chart shown with the original 2 tags plus a dashed limit line displayed across the chart. In the next appearance setting, we'll look at how data points are interpolated when plotted. Let me first remove the last tags used and add a new tag to the chart for the last 15 minutes. I'll add the same tag again using the same time period. Now what I'm going to do is go back to the appearance settings and set the interpolation type for each tag. We go to the chart type settings for this. The default is value based. This setting will connect the value points with lines, sometimes called linear interpolation. A time-based setting will draw a horizontal line of a value until the time point when the value is changed. This line type is typically used to display a line chart for binary values, such as a chart of motor or valve states, or for analog tags such as set point changes. This is sometimes called a step line. Please note that this plot style can be set individually for each pen. Let's save this report and generate it. Notice that while some points are plotted, the blue pen uses linear or value interpolation to connect the points, while the brown pen holds the value with a flat line until the next data point, and so on. In the final appearance setting we'll look at, we will see how to handle a tag whose data does not cover the entire report period. For instance, if we only had data logged for a particular tag for the past week, but the rest of the tags were charted over the past year, the first tag's plot would appear highly compressed and unreadable on the right side of the plot. So let's set this chart duration to be the last 15 hours for the same 2 tags. We'll use the chart window option to fit the data to this time period. For the first chart, we'll use the default fit to time period. This means that the entire time period defined for the chart will be shown, regardless of where the tag's data falls. For the second chart, we'll select fit to data for the plots using the same tags and time periods. Let's save this report and then generate it. Notice in the upper chart where we used fit to time period, the entire 15-hour period is shown, but only the small amount of data logged for those pens is shown at the right side of the chart. In the lower chart, Dream Report finds the timestamps of the first and last data points and uses those as the date range on the x-axis, making it much clearer to read. The final topic we'll cover in this video is interactive web charts, a feature introduced in Dream Report 4.6. This feature enables a user to interact with a line chart in a Dream Report web report, such as zoom in and zoom out on a chart area, dynamically switch on and switch off lines on a chart, display tooltips with values with a mouse hover over a point on a line chart. Make sure that the report format is set to web for the specific report. Once we save the report, we'll open the Dream Report web portal and click on this new web report. Here we see the web chart with multiple tags. I'll click Zoom In and Zoom Out buttons to get more detail. Next, you'll see that I can hover over any point on a line and get the tag name, the instantaneous value, and timestamp at that point. I can also turn pens on and off simply by clicking the trend legend, This allows me to focus on a single tag if necessary. You'll notice that you can drag all pens at once to focus on a particular area, and the X and Y scales update immediately. You can also use the mouse wheel to zoom in or out. And finally, click this button under the zoom buttons to return the chart to its original layout and scaling.